In this problem, we need to determine the equation of the images of a circle of radius 4 units lying in the first quadrant when reflected across the lines x equals to 0 and y equals to 0. So let's first try to understand the problem graphically. So we have a Cartesian plane with the x and the y axis, and we have a circle with center C, and it is touching both the two axes. You can say it is tangent to both of the x-axis and the y-axis. The circle has a radius of 4 units. Now our goal will be to determine the equation of not this circle but a circle which is reflected across the line x equals to 0 and y equals to 0. So first let's work with x equals to 0. So the line x equals to 0 is actually the y-axis. The y-axis has the line has an equation x equals to 0. So we are going to reflect it about the y-axis. So we get a circle on the second quadrant. So we're going to call its center as C prime, and this circle is also going to have a radius of 4 units. We'll have to determine the equation of the yellow circle. And if we consider y equals to 0, y equals to 0 is actually the line, the x-axis. So x-axis has the equation y equals to 0. We'll have to reflect the circle, the original circle with the center C, about the x-axis, and this is going to give us the circle with center C double prime. Fine. So let's find out each of the equation. So here we'll be using the standard form of a circle. The standard form of a circle states that if we have a circle whose coordinate is given by, coordinate of the center is given by h comma k and has a radius of r units, then we have its equation given by the formula x minus h whole squared plus y minus k whole squared equals to square of the radius. So we'll begin with our yellow circle. We will need to determine the information regarding the coordinate of the center C prime and the radius. The radius is fine, that's 4 units. We'll start with our original circle. Then the original circle, let's drop a perpendicular from the point C, or from the center to the x-axis as well as to the y-axis. So this is nothing but the radius of the circle, and since the radius of the circle here is representing the x and the y coordinate, the center is going to have a coordinate 4, 4. Same goes for the yellow circle. All we have to do is drop a perpendicular from the center C prime on the x-axis as well as the y-axis. Now the height, which is going to be 4 units, and the horizontal distance is also going to be 4 units, and we are going to get the coordinate of C prime, that's going to be negative 4, positive 4. Negative 4 because we are on the negative x-axis. So that means we have a center which is h comma k, and we found out for the yellow circle it's negative 4, positive 4, and the radius is going to be fixed at 4 units. Or we can use the standard equation of the circle. Thus we had x minus h, so h is negative 4, we get x plus 4 whole squared added to y minus 4 whole squared, and this is going to be equals to the square of the radius, so that's 16. Similarly, coming to the blue circle, so we'll drop a perpendicular from C double prime on the x-axis as well as the y-axis. This is nothing but the radius of the circle, and from here we can find out the coordinate of the center, so that's going to be positive 4, negative 4. Positive 4 means we are on the positive x-axis, negative 4 means we are on the negative y-axis. So the radius, since it is fixed at 4 units, our equation will be, or equation of the blue circle will be x minus 4 whole squared plus y plus 4 whole squared equals to square of the radius, so that's 16 units. So that means we have finally found out both the two equations. This particular equation represents the reflected image, equation of the reflected circle about the line x equals to 0, and the blue circle, this particular equation is going to represent the equation of the circle that is reflected about the line y equals to 0.